Okay, and then minus t t, and then we can split it into actually if we draw this the xt being the graph is being like this. So this is minus infinity, this is positive infinity. So we want to divide it into two parts. First, let's say this is first part, this is second part. So we draw the integration between minus infinity to the 0, and then the e is minus no minus. In this case, this is minus minus. T plus and then we arrive at these expressions s minus 1 t plus 0.
Sir?
Yes.
I think the whiteboard is not showing.
Oh, are you? Oh, okay. Sorry. So the whiteboard. So wait a moment. Wait. Oh, I'm sorry. Mana punya saya yang nggak ada. Okay, wait a moment. I think. You can see my whiteboard.
Yes, sir. We can see the whiteboard.
Okay. Maybe I will repeat for a while. So this is the xt, and at the xt we can draw maybe for visual representations for easy understanding. You can see here is like a mountain with the slope here, and the negative part and the positive part here, and then we split it into two area. This is the first area, this is the second area. Actually, we can draw like this. This is the first area and this is the second area. And then the first area become this one. We can combine. And then for the second area, we can simplify being minus 1 plus s t dt. Okay. And for this, oh no, this is it should be 1 minus s. If you can see, the s is contributed to the negative part. Okay, in this case, so we can integrate using simple integration. 1 minus s, and this is 1 minus s t This is 0. And also this one also minus s. This is a minus plus s, yeah. B this is 0. So the result in this point is become 1 minus s plus 1 plus s. Yes, that's right. And then the result is become 1 minus s. Okay. Okay, until this part, do you have any questions?
No questions so far, sir.
Okay. And then we draw the ROC here. This is the imaginary part. This is the real part of S-plane. And then for the first part, you can see here as, yeah, minus, it should be less than 0. So in this case, it's like minus 1 plus s less than 0, s is less than 1. So we draw this one for the first area less than 1. So the area is here. And for the second part is minus 1 plus s should be less than 0 as well. Yeah. So in this case, minus s 0 and minus 1 s. So s should be greater than minus 1. So we draw here something like that. So we can define the ROC. ROC is the real component for S is between or less than 1 and greater than minus 1, something like that. That's the result. Any question?
No question.
No question. Okay. So we move forward and then clear this one, and then we move forward to the next problem. We have XS signal in domain S and then become S per S powered by 2 minus 4. Yes. And define the xt. Define the xt. And then first step, we can partial fractions using method of partial fractions. So the xs will be divided into something like that, and then actually this one become s plus 2 and s minus 2. How this is just a factorial, yeah, factorial. The denominator is just factorial of this component. Actually, for looking for the A component, the A component is just, yeah, 2s here. S plus 2 is just similar to this one, s minus 2, and then submit it to s. As to so this is 2 minus 2 times minus 2, and this is minus 2 minus 2, and this is become minus 4. This is minus 4, right? And this is become 1. And for the B is still same, s plus 2, s minus 2. This is time s minus 2, and then we substitute the s is become 2, and then we reduce this one, and then 2 times 2 and 2 plus 2, and then become 4 by 4 and become 1. And then the final result is 1 s plus 2 plus 1 s minus 2. Okay. Okay, and then let's say this is the first component. Let's say x1s, and this is the x2s. And for the x1s to the xt is just a lookup table. Yeah, you can check by in the table. To those who already understand, we can write easily become the xt become a minus 2t. Okay, and for the x2s,
Masuk, Adi.
the
Masuk.
e minus something like this, and then we got the This is the xt1 t, and this is the xt2t here. So the xt become a minus 2t plus a minus the positive 2. Yeah, that's the result. Any questions? Very simple.
No, sir, no question.
No questions? Okay. Okay, the last part is the number 3. Yeah. Become this one. This is 3yt divided by dt plus 2yt equal to this dot t. Okay. And then the simplest way to solve this problem, which is the problem how to express the yt using Laplace transform actually, yeah. You remember that the first derivations of Laplace transform, we just multiply using s component. So in the first part, we can draw beam like this, s power by 2 ys plus s ys plus 2 ys. And for this component, the dou or the impulse become 1, right? And then S2 plus 3S plus 2 become like this, ys 1, and the ys become 1s plus 3s plus 2, right? And then you can solve using a partial fraction, right? A plus b, and the factorial is become s plus 1 and s plus 2, right? Any complaint, any questions? And then we find the a. The a is 1 s plus 1 s plus 2, but in this case multiply by s plus 1, s substitute with s minus 1, and then we reduce this one, and 1 minus plus 2 is equal to 1. And for the b is okay, still same, 1 s plus 2 times s plus 2, and then we substitute minus 2, and then we 1, and this one become minus 1, right? So the result is minus 1. So the ys become 1 s plus minus s plus 2, right? And then we can direct conversion to the times component. So the yt become equal to, yeah, I write become like this, I minus e minus t. This is minus e to t. Okay. Okay, that's the result. Any questions?
No, sir, no question.
No, yeah.
Next person. Microphone.
Yeah. Any question, Nail? Maybe you have question, Nail?
No, just thinking, can we not decompose more? Pa?
You want to decompose more? What do you mean?
Mm.
When you use partial fractions?
Mm-hmm.
Yeah. When we using partial fraction here, we a bit tricky. I mean, first you have to determine the factor of the denominator, and then after that you can split it become several part based on the number of the factorial. Yeah.
Mm. I found that my lower base was the same answer as a square plus 3s plus 2. And I think it has two roots plus minus 2 and minus 1, if I'm not mistaken. So in the bottom, it was s plus 1 times s plus 2. And then in the nominator, it was s plus 2 as well. So I divided, and the answer was 1 over s plus 1.
So you found the corrections.
2s, y.
Okay. Okay, yeah. Okay. And okay, if yeah, then I want to stop share this one, and then I will want to share this another screen. Okay. So everybody can see, yeah. So actually, the Laplace transform already finished for the material, yeah. The topic of Laplace transform already finished. So we move forward to the zeta transform. Z transform. So in the screen, there are many relationship, yeah, relationship. First, this is a system block diagram representations. Wait a moment. The left top one, the left top box, this one is block diagram representations of the system. And this is the system functional. And then this is representing the system in different equations. And this is the system function in Z transform. And all of the representation can be write using unit sample response. Yeah. So so I will divide you into maybe how many group, yeah. 5 group, yeah, 5 group to explain, yeah, to explain for example, how we can first explain this one, and no, wait a moment. Clear. Okay, so the first group, I expect you to explain how to convert the block diagram to the differential equation. This is the first group. And then the second group, how to explain the block diagram to the system functional like this. And then the third group, how to explain from the functional become this one. Yeah, become this one. And from the number 4, how to explain this functional system in R to the Z. This is number 4. And number 5, how to explain the unit sample to the Z. Okay, I hope it is clear. So I save this one. Wait. Okay. So I will give you the signal, signal and system. So okay. Okay, then I will divide you into 5 rooms. Okay, so is that clear for the task, everybody?
Yes, sir.
Okay. How to explain? You can explain by PowerPoint. Maximum only one slide lah ya, one slide, and then or you can explain using writing by hand, writing in whiteboard and then explain, and then or maybe those alternative, only two alternative. Okay. Okay, you have maybe 30 minutes. 30 minutes. And then we meet again in the main room. Okay, be ready. I will break you randomly into 5 groups.
Why is only me here?
Okay, thank you everybody. We are getting back to the main session, so it is time to present and discuss what you have learned, what you have found from the problem that I already give to you. Okay. Okay, we start with the first group. First group will explain how to convert from the block diagram representations to the differential equations. Yeah, please, group one. The group one will be delivered by Ayas, Dava, and Naufal Aulia. Please, time is yours. You can also use the screen sharing.
Okay, sir.
Yes.
Okay, sir. I will start screen sharing.
Yeah.
Okay. Can you see my screen?
Yes. Clear.
Okay. So, good afternoon, everyone. We are from Group One. We will explain about the how to convert from block diagram to the difference equation. And wait. Okay.
Hey, hello. Okay, so wait, let me annotate. Okay, so we are given a block diagram of this, and we convert it into a difference equation. So yeah, basically, the input of this block diagram is the xn, while the output is the yn. And then, as you can see from the problem, there are two delays. The first delay right here, and the second one right here. And pay attention to the what is it called, the variable of the delay, like this. This is the delay is y. So it flows from the end from here into the input, and this part here is the y n minus 1 right here. And we also have the second delay here, which flows through here, wait, like here, and yeah, the magnitude is y n minus 2, since it's the second one. And basically, when you have obtained of this one, this tree, you just sum it up. Yn equals to xn, yeah, plus y n minus 1 plus y n minus 2. And for example, if the delay is like this, x n minus 1, it will flow from here through the end, like here. This is the delay for x n minus 1. And yeah, it's pretty much of our topic, sir. Should we also explain some example if we from the difference equation converting into block diagram?
I think it's enough. But if your friend requested to give Next sample is okay. Maybe asking to your friend, is there any additional explanations? Audience? Yes, no? No? I think it's clear. Very good. Thank you, Group 1, Ayas and Dava and Naufal. Thank you. And then the second group is Goldie, Nadia, and Raihan Safero. Please prepare your presentations. Yeah.
Can you see the present the
Yes.
paint?
Yes, perfect.
Okay. So this is the how do I say it? Can I annotate here? Okay. Okay, so this is the block diagram, and this is a system function. And how can we get from a block diagram right here into something like this? So based on what we have learned from the internet, from other sources, from the books, it says that a system functions is that it's an output and divided by the input. So since so a system function is an output divided by an input. Please excuse my writings. Okay. Okay. Now, since okay, the output and the input. Now here in this block diagram, the output is y, and uh, the input is x. So we just write it right here that it's y divided by x. Okay. Now the y divided now here an input an output is represented by the number 1, because an output is an output. It's a result of the input, but the input is what we can try to break it down one by one. So in system functional, a delay is represented by the letter R. So here's an R, and here is an R. And in this block diagram, we know that this is a summing point, summing point. This is as well a summing point. I'll just do it like this. This is a summing point, and here point right here is called a takeoff point. So what does it mean? Takeoff points, as we know, like airplanes take off and all that stuff. It means that we started from here, the takeoff point. So in this, but if okay, so to analyze this, we look at each of the summing point. So at the first summing point, here is, we know that here a delay is how do I say it? So here in this diagram, there are 2 delays, and we try to look at this summing point. In this summing point, x or 1. So this is we represent x by 1 here. So 1 is summed with a delay, but this delay in particular, so this delay is is actually a delay version of the later delay. So this delay is being delayed by this. So as we know, the function is like r. Sorry, it's not r. It's r times r, because a delay, this is a delay being delayed by another delay. So and since it goes back from the takeoff point to the summing point back, it's like it's a delay. So the magnitude is minus. So this is minus R, sorry, this is probably like this, minus R times R. Okay. All right. And well, now if we try to look at this point again, now we know that from this summing point, it results in this equation, the 1 plus, sorry, the 1 plus e y is not, okay, the output of the summing of this summing point is okay, the output of the summing point is 1 plus minus r times r. So here we can write this as 1 minus r times r, or r squared. Okay. Now, as the second summing point, it is also the same like in how we analyze the first summing point. So for the second summing point, 1 minus r squared is summed by a delay. So a delay is basically an r, and since it goes back from the takeoff point to the summing point, the magnitude is minus. So what we have to write, since we already have the output here, we just have to add plus an r, a delay. Sorry, minus r, because the magnitude is minus. Okay, minus r. Now, since we already have this equation, we can then simplify the equation into 1 divided by, sorry, bad writings, 1 divided by 1 minus r squared. And there we go. That's how we have the system functional equation of the block diagram.
Okay, thank you, Savero. Maybe before you close your screen, maybe the audience may have questions. Audience, or maybe agree or not agree, or just simply clear, crystal clear, something like that.
I think it's crystal clear for me, sir.
Oh, crystal clear. Okay, Arvigo. Okay. I have a question, maybe, Savero.
Yes, sir.
How do you determine? I mean, you say here is y is just simply says 1, right? Y is 1.
Yeah.
How do you can get that value?
Actually, sir, I didn't try. I didn't dig that value up because, well, this is I learned this from another examples on YouTube. It says that when an output is represented by the minus, sir. So that's why I just put minus there.
Okay, okay. Please look at to the denominator. There is minus r, yeah, minus r and minus r. And how do you get that minus?
I think the minus coming from, since a delay. So the delay is going from the end, almost at the later end of the diagram. So since it's coming from here, I think the directions goes to the left. So it means that it kind of reduct the value of this okay, say there's a value here. This value is being deducted by the delay, as in the previous group has explained.
Okay. Okay. Yeah.
But maybe I'm wrong. Please correct me if I'm wrong, sir.
It is not the day of judgment. Okay. Anyway, okay. Allow me to maybe give another perspective. Actually, yeah.
Yes, sir.
I'm not sure that. Yeah, maybe it's correct, maybe it's wrong. I'm not sure. Because the explanation is quite long, and yeah, sometimes it's I don't know. Anyway, please allow me to make a notations.
How do we do
At the
that?
top of the screen, sir, there's few options which you can annotate.
Yeah. But accidentally the annotation is disappeared. Which request
Or
remote?
do you want me to stop sharing, sir?
No problem. Okay.
Oh, okay.
Okay, I can control. So I'm not sure. I think control keyboard. I'm not sure. Wait a moment. Maybe I'm too old to use keyboard. Give up show meeting show meeting control show meeting control. Ada ya. I'm not sure. I don't know. I cannot make annotation here, but you annotate. Okay, just appear. Okay. Actually, this is in my perspective. Actually, yeah, we can draw from the group one. Actually, from the group one, we can draw the output. Yeah, the output is being like this: the xm, yeah, plus y, and this is due to the first delay. Yes, and this is due to from the second delay. Yeah. And then we just move to the left one, this part and this part. So we can write yn minus yn minus 1 minus yn minus 2 and equal to x. Yeah. And then if we consider that the yn is just yn, or like let's say is yeah, the yn, and the yn minus 1 is just yn, but it's kind of like a delay, right? So we can put like this the yn, and this is for the 2 times delay, so just we put like this. Maybe some of you asking, what is the error? What is error? Error is a function, right? The function that makes the y become delay. So in this case, we can write being like this, and this is 1 minus r time r, and become yn and become xn. And then we changing the positions, and then we can write beginning yn minus xn 1 plus minus r, something like that. Okay, any questions? Yeah, the final result is similar, but I hope it is more convenient to be understood.
Yeah, I think this is better explained, sir.
Okay, no problem. It's just because I'm experienced.
Yeah. So if I
Okay.
may confirm, sir, I think to try to derive a system functional from a block diagram, first we have to do we have to find the difference equation. Is that correct, sir? And then from the difference equation, we can then obtain the system functional.
Yeah.
Okay.
Okay.
Okay, sir.
Okay. Yeah. 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 Okay. Any other questions? Okay. No. Okay. If no, thank you from group two. Group two. Yeah. Thank you,
Yes.
Savero and friends.
Yes.
You
Thank you,
can
sir.
close. Yes. Okay, the next group is group three, consists Arvigo, Ferki, and Sanditya. Please prepare your presentations.
Hello, sir. Is it visible, the presentation?
Yes, already visible.
So, hello, everyone. We are from Group 3. We are going to try to explain about functional system that is transforming into the unit step response. So, based on the explanation from Group 2, from Savero before, and from user, we obtain the functional system from the block diagram. So, let me share screen. Okay. So after we obtain this functional system with 1 over 1 minus r square, we just divided both of them. So we divided 1 minus r2 towards 1. Oh, maybe I just noted. So here we divide 1 minus r square into 1. So we first allocate here one example, like this is 1. So we time multiply 1 into this 1 minus r square. So we obtain, here we eliminate, we subtract, and we obtain r minus r square. And so this is too large, I think, the writings. And here we times again to accommodate r here, we times r again. This r minus r square minus r. And we continue this until, I think it's basically the series is in until infinity. I think there's no stopping the series of this divide this uh, divide. So there is no stopping this answer. So it's continuously acting as a series. So here we get HR. I just oversimplify the directly to the answer. So here we get HR is equal to since the calculation is taking too long, so I just calculate the answer. I just determine the answer as HR equal to 1. Oh, sorry. 1 plus R plus 2R squared So this is the comparison between 1 over 1 minus R squared. And we continue. After obtaining that, we just express the hn to this, like from the constant coefficient value of hf. So like only the constant value before the r, like hn is 1, comma 1 and comma 2, comma 8, comma 13 based on the previous answers, like the only the coefficient values. So this is the unit step response from the functional system. I think it's that's also from us.
Okay, thank you, group 3. I think that's perfectly correct. Yeah. Is there any questions? Maybe from another audience, yeah, another student. No, yeah. No, it's clear. Okay, if clear, we forward to the next group. Thank you, group 3, Arvigo, Firki, and Sanditya Larope. And then from group 4, please prepare your presentations. Yeah, Abias and Daniel Siboro.
Yes, sir. One moment.
Yeah.
Okay. Can you see my screen? Can you see my screen, sir?
Yes.
Okay. So for my group, I need to transform or convert the system functional into the system function. So the system functional variable R is defined in the Z as R equals to 1 over Z. So if we want to convert the system functional into the system function, all we need to do is plug in the variable 1 over Z into R. And then we can plug in here 1 over 1 minus 1 over Z minus 1 over Z squared. And then we can simplify it to get the system function. I think that's it for the explanation.
Okay. Okay, it seems to be correct, but my question is why we need to multiply with this one?
Oh no, I'm just simplifying the equation, sir. Into so we get this one, right? So I multiply it with z squared over c squared so that I can get the equation from the picture you give us, so that we can get the this one,
Oh, okay.
just to simplify.
If we don't multiply with this one, or the result's still correct, right?
Yeah, the result still the same. You can simplify it however you want, or just let it be the same.
Okay. I understand. Yes, thank you. Thank you, Daniel Siboro. Anyway, please keep this screen on. And is there any question from your friend, maybe? So in this case, we can replace the R, yeah, the R with just 1 over Z, right? Over Z. So it's kind of multiplied by Z minus, yeah, power by minus 1, yeah, something like that. Yes, and then we got the completely the function in Z domain. Actually, you already done with the Z transform. Yes, using your own method. Okay. Okay, thank you, Daniel. And then Daniel and Abias, yeah. Okay, thank you. And then we move forward to the group 5, Neil and Robbie Arsa. Yeah, please prepare your presentation.
Okay,
Neil and Robbie, yes.
I will share whiteboard.
Yes.
Okay, can you see it?
Yes.
So Robbie, I made a presentation too in the slide. How do
Maybe I will first explain with whiteboard first.
Okay.
So we gonna convert from the unit sample response to the system function. So before we can convert, we have to know the relationship between the HN and between the unit sample response and the system function. So the unit sample response, which is HN, relationship with the transfer with the system function, which is HC. Okay, we can get an equation with something like this. What? Sorry. So we can say that from this equation, we can say that the hz with the system function is the z transform of the hn. So now we can get to the example shows in the presentation. So in the presentation, the unit sample response is this. So it resembles a Fibonacci series, right? So we can get from this unit sample response, we can get the difference equation. So we can write it like this: the equation of the Fibonacci series. Then we can use the Z transform to make it as the system function. Okay. Using Z transform. Okay, because it is too long to explain the transform step by step, so we can get the transform from like this. That. So next is can make it as the the system function is equal to yz to xz. So from the previous this transform that we have do, we can get this. So this, so it is the same as the one in the presentation. something like that.
Okay, thank you, Robi Alta. Yeah. Okay, seems to be correct. Yeah, seems to be correct for the final result. Yeah. Okay. Okay. Please wait. We are having Adhan for a while. Okay, then finish. Let's continue. Yeah. Anyway, Neil, do you have material for? Oh, Neil is disappeared. Okay, no problem. Okay, allow me to annotation. Yeah, annotation. Okay. Yeah, it seems to be correct, but yeah, sometimes expressing unit sample to the Z transform sometimes is straightforward, sometimes also a bit complicated. Yeah, for example, we have
Hi, Pops, the Zoom drop it when you ask me.
yeah, no problem, no problem. So you are okay now? Okay.
Yeah.
Okay. Let's say we have a unit sample here. Let's say 1, 2, 3, yeah, 4. Yeah, this is a finite unit sample, and then we can for the representations. I mean, let's say this is a 0 here. I mean located at 0, so we can write thing like this. This is 0, and this is for the 1 is 2, the magnitude is 2, this is 1, and for the 3 this is 2, and this is magnitude is 3, and the 4 is 3, this is magnitude is 4. Okay, in this case we want to convert to Z transform. It is very easy. Let's say from this one, so we can write become Z, yeah, something like this. And this component, we start from this component, actually 1 multiple by Z minus 0. Actually the 0 is coming from this. And then is 2 multiple by Z power by 1 plus 3 times Z, this is Z, power by 2 plus 4 Z power by 3. Yeah, it's very simple. This is 1 and this is 2Z1, and then 3Z minus 2 plus 4Z minus 3. That's all. Okay. And then you can manipulate, for example, become nominator and denominator. That's up to you, but until this point that's enough. Yeah. Okay, allow me to clear. And then also in this case the HN consists of 1, 1, 2, 3, yeah, 5, 8, 13, and 20, and so on. Okay. So in this case, we can write Z transform become 1 Z minus 0 plus 1 Z minus 1 plus 2 Z minus 2 plus 3 Z minus 3, yeah, plus 5 Z minus 4 plus, and so on and so on, and this is infinity. Infinity. And this form sometimes it's yeah, you can see it's long enough to write, and we don't know what is the end. Actually there is no end. And then this is another way to represent, yeah, it's like a series, and sometimes it is tricky to know, yeah, tricky to know the series, yeah, I mean to know the compact version. It is to know to know the compact version. Actually there is available how to take this kind of series to be a compact version. You can check again in Advance of Mathematics. You can how to find the compact version from a series. Yeah, because this is a kind of series. And if you have a difficulties to write in compact series, yeah, we back again to the expression of hz. It is hn summation from minus infinity to the positive infinity and z or minus n, something like that. And and then you can just get back again to the expression of HR. Actually, R is not the transformations. Yeah, as R is just intermediate method, and then submitted when the R equal to something like that, and then the result will be something like this. Okay, that's all. Is there any questions? Wait moment. My home has experienced blackout of electricity. Okay. Display setting. Change.
Maybe I can turn off the whiteboard.
Oh yeah. Only one. Okay. I think. Okay. transform and step one. Iya, tunggu. Sebentar. Ayah belum selesai. Okay, that's all my explanation, and this is just preliminary for Z transform. Actually, so far what we can conclude until now, the Z transform is converting the signal from time domain to the Z domain, to Z domain. Yes, and what is the requirement for the signal to be transformed to the Z transform is the signal in time domain should be discrete. This is the opposite of Laplace transform. When the Laplace transform is converting from continuous to the S domain, and for the Z transform, converting from discrete time to the Z domain. Actually, what is the differences between in terms of the domain? Laplace or S domain or Z domain, it's almost similar, consisting the real and imaginary part. Yeah, but the only differences is on the signal in time domain. Yes, the Laplace is continuous, and for the Z transform is discrete signal. And that's all our course today. Is there any questions maybe?
Sir,
Yes.
regarding the previous exercise, I happen to be not submitting my work. That is because yesterday I have a force majeure where I have to go to Bandung to a hospital to look after my grandfather. So is there any chance that I can submit my work, sir?
Yeah, you can submit. Uh, you can still submit. Yeah, to Thomas.
Okay, sir. Thank you very much, sir.
Yeah, actually, those assignment is for exercise. No need to be kind of score. There is no need to be score, so everybody can submit again. Okay, that's all. Thank you very much for your attention. Any other question before we closing? No. If no, thank you, and stay healthy, follow the protokol kesehatan, and see you next week. Assalamualaikum warahmatullahi wabarakatuh.
Excellent, Pak. Thank you.
Waalaikumsalam. Thank you very much.
Waalaikumsalam.
Thank you,
See
sir.
you next week, sir. Thank you very much.
Yes.
Waalaikumsalam. Thank you, sir.
Okay.